Welcome to the Backyard Bounty Podcast from HeritageAcresMarket.com, where we aim to educate and inspire you by sharing practical information to help your homestead thrive. And now, here's your host, Nicole.
Hello, everyone, and thank you so much for joining me for another episode of Backyard Bounty. I'm your host, Nicole, and today I'm joined by David Gadoury, who is a plant pathologist at Cornell University and host of the Plantopia podcast. And today we are going to talk about plant pathology. So, David, thank you so much for joining me today.
And thank you for having me.
Absolutely. You know, I honestly don't remember how I discovered you, but when I found out that a plant pathologist was a thing, I was definitely intrigued, and I definitely wanted to learn more about plant pathology and how that knowledge can help us in our everyday lives. So can you kind of tell us, what is a plant pathologist? What do you do? What's a day in your world look like?
Well, it's a very diverse profession and a very small one, but a very important one. It's easy to go your entire life without encountering a plant pathologist. There's about just over 600 of us on the U.S. university faculty across 50 states.
Oh, good.
I did a study once for our professional society where I compared the number of courses offered in basket weaving at U.S. universities, and there are more courses in basket weaving than there are in plant pathology, in introductory plant pathology.
Goodness.
So we're somewhere around basket weaving on the horizon. And yet we're...
What about underwater basket weaving?
That's a specialty. We do have specialties within plant pathology. So we're a very small profession, but a very important one. We're charged with protecting the world's food supply. And so we do that. Now, the profession's actually a little bit larger than that because the university faculty is only a small part of the profession. There are actually many more people in the advisory services across the country, cooperative extension, private farm advisors, and people connected to the university but who are not professors but are in the advisory service. And then there's a large private sector that's made up of private practice and also people working within various industries that employ plant pathologists. And then there are government agencies as well, like the Agricultural Research Service of USDA has a large contingent of plant pathologists. As for what we do, it's a varied and diverse profession. So we have epidemiologists, sort of like Dr. Fauci, people who study how plant diseases spread within populations of plants. We have taxonomists who study how plant pathogens should be classified. We have specialists in viruses as plant pathogens, as nematodes as plant pathogens, fungi as plant pathogens, and bacteria as plant pathogens. So you have bacterial plant pathologists and fungal plant pathologists and everything in between.
And so what are some things that you researched or that you yourself has worked on as a plant pathologist?
Well, I'm one of those epidemiologists.
Okay.
And so I study how particular groups of pathogens develop within populations of specific hosts. So my specialty is within the area of what we would call specialty crops, high-value fruits and vegetables. And I tend to work on diseases caused by fungi. And then within that group, I specialize on a group of pathogens called powdery mildews and downy mildews. Two pathogens with very similar sounding names, but very different life histories and epidemiologies.
And so are those ones that were of particular interest to you, or how did you get involved in those?
Quite by accident. In fact, that's the way many people become plant pathologists. You don't really when someone applying to graduate school tells us that they've always wanted to be a plant pathologist, we know they're lying. Because no one discovers this profession from childhood unless they are the child of a plant pathologist. You generally discover it late in your undergraduate career. So how did I get to where I am? I blundered onto a course in plant pathology as an undergrad, and then I actually worked a summer internship in a diagnostic clinic. From that, I ended up applying to plant pathology graduate programs. I went to the University of New Hampshire for my master's and PhD, and then I accepted a position at Cornell University, and I never looked back. That was 35 years ago.
Oh, wonderful. So what are some of the most important or most profound or surprising things that you've found so far with your research?
Well, of course, the most important and profound things are what I work on.
Sure, of course.
For several years, I've been working on a disease called grapevine powdery mildew. So if you're a grower of wine grapes in the United States or really anywhere in the world, you know a lot about this disease. It's the most widespread and destructive disease of grapevines worldwide. And we've more or less made our own mess with respect to this disease. The pathogen group is a native of eastern North America. This is the center of origin, right around where I live in upstate New York. So the pathogen existed here on wild grapevine species for millennia before it encountered the European wine grape, which is a different species from those found in North America. That's Vitis vinifera. That's the European wine grape. So all of the fine wines that you might encounter, Chardonnay, Pinot Noir, Cabernet Sauvignon, all of these are varieties of Vitis vinifera, the European wine grape. The French gave us the Statue of Liberty in the 1800s. We gave Europe grape powdery mildew. It was exported on planting material to Europe, and it spread throughout the continent. It very nearly destroyed the European grape industry in a few years. And it was only brought under control by widespread use of sulfur as a fungicide in the 1800s, which is remarkable because the European population of grape growers using a fungicide even before germ theory was widely accepted. So they're battling a microbe before they even really knew what was causing the disease. So that's what I work on. I do a lot of work on grapevine powdery mildew. I've been studying how it survives winter, how it reinitiates epidemics, when the host becomes resistant to it, and when we can best intervene to disrupt an epidemic, to prevent it from destroying the crop. And we've made a number of advances in that area that have changed the way we approach controlling that disease in the United States and worldwide.
And what are some advances?
Well, you'd think a disease that had been studied as intensively as grapevine powdery mildew, for 150 years, that we would know everything there is to know about this disease, but we don't. There were some very basic things about how the pathogen reinitiates an epidemic that were unknown or were misunderstood. One example. Early in my career, I worked on how the fungus survives winter. It was thought that the pathogen really overwintered and survived in cold climates in a vegetative state inside dormant buds on the grapevine. Now, there was a second form of overwintering that was observed but was assumed to be non-functional. And it was really because we were looking in the wrong place for the living structures of the fungus. They were actually residing on the bark of the vine in bark crevices in a place we never would have thought of looking for them. They were dispersing from the mildew colonies on the leaves during the autumn into the bark crevices, and they'd more or less been hiding out there right under our nose for over 150 years. So that discovery led to targeting fungicide sprays towards that particular source of infection. And that changed really how we approached controlling the disease, and it improved the performance of fungicide programs used against the disease. So control got better, and we actually used fewer fungicide sprays. So that was one contribution.
So obviously, I'm sure that the grapevine growers are quite thankful for that contribution and that discovery.
Yeah, it was a while ago, though. Those that are still alive, I remember the work, but remember, I've been doing this for 35 years now, so I'm in this for the long haul. There was another case where there was a misunderstanding over when the grape berries actually become resistant. There was some very early work that had mentioned that the berries were susceptible to powdery mildew until they accumulated about 8% sugar, which is in our climate sometime in mid-August. When I searched back through the literature, and this is a common thing that actually happens in science, someone, perhaps a very respected researcher, will make a speculation at some point in their career and say that something like, I think berries are susceptible until they accumulate about 8% sugar. And they will write that down, or it will be written down by someone else. The next time someone reviews the literature and sees that, it will be reported as so-and-so observed that grapevine berries are susceptible until 8% sugar.
Oh, no.
And 20 years later, it morphs into, it has long been known that grape berries are. And so when you trace back through the literature, often you find that some of these things we consider as the bedrock of a decision-making process may be nothing more than speculation. Now, it might be an informed speculation, an educated guess, but it's not data and it's not a conclusive study. When we actually did an experiment to determine when grapevine berries become resistant to powdery mildew, we found it was much earlier. They're actually only infectable for about 2 weeks. So compare that period of very high susceptibility of 2 weeks to what we thought we were dealing with, which is more like 2.5 months.
Sure.
So the period during which they needed to be protected is actually much shorter. There's a couple of things wrong with that when you're trying to design a management program. One is that you're wasting a lot of time protecting the berries from infections that can't occur. The other is that's a really narrow window of susceptibility, and it's easy to miss. So if you're just putting on, say, a fungicide every 2 weeks, you might be on the wrong side of that window and entirely miss the most important period for suppressing the disease. It's like giving a vaccine after the fact, after the host is infected, or too early in a life or too late in a life. It's not that the vaccine is ineffective, it's that it's not synchronized with the period of risk. So that was another improvement in the way we approach controlling this particular disease.
So how do you know when you're in that window?
It's possible to do by repeated inoculations, repeated infections of the host in a carefully controlled setting. So we can protect the host and then leave it in a susceptible state at different stages in its life. And through the outcome of those controlled inoculations, we can tell when it was susceptible and how susceptible it was at a particular time.
And then, so you mentioned working on powdery mildew and then some other research as well. Can you touch on that as well?
Well, yeah, that's the other pathogen group with a similar sounding name but a very different life history, and that's the Downy Mildews. Now, the Downy Mildews are not really even fungi. They're in a group called oomycetes, which are very more closely related to algae than they are to the true fungi. So they tend to be water-loving. They have swimming spores that look a little bit like microscopic polywogs, and they can swim in the water film on a plant, and they infect through natural openings, usually in the leaves or sometimes in flowers or fruit. So the breathing pores in a plant, the stomata, these are natural openings, and they are the route of infection for these swimming spores. So powdery mildews are very special in the fungal plant pathogens. Most fungal plant pathogens produce these infectious wind-blown spores, and they're sort of like plant seeds. They require water, and they actually go through a germination process. So if you can imagine a powdery mildew spore flying through the air, lands on a host, if it were anything but a powdery mildew spore, it would require a water film. That's what starts the germination and infection process. Powdery mildews actually carry their own water with them.
Oh, wow.
And that's what allows them to germinate on a dry plant surface and what makes them such sometimes very aggressive pathogens. Downy mildews are almost the opposite. They produce swimming spores that require a water film. And so they land on a leaf and then they release these swimming spores and they swim to the stomata, generally on the underside of a leaf, and they infect. They will then grow for a period of time, and then they will reemerge through those same stomata and produce new spores and start secondary cycles. And that repeats many times during a growing season. During wet weather, these can be really explosive epidemics. You can go from 0 to complete losses in a period of just a few weeks. And that's one of the things that makes these diseases a little bit scary, is that they seem to come out of nowhere. And they can be very destructive. Probably the most historically important example of that is late blight on potato, which is the disease that caused the Irish potato famine in the 1800s and caused the starvation of thousands upon thousands of people.
Mm-hmm. So you mentioned how the grape powdery mildew overwinters. Does the downy mildew overwinter on or around plants as well?
Most pathogens have evolved to adopt some strategy to keep them near their host. So the downy mildew pathogen is one of those. It produces a second type of a spore called an oospore that is formed within the plant tissues. On a grapevine, it forms within either the fruit or within the leaves. Grapevines are what's called a deciduous plant. They drop their leaves at the end of the growing season. The leaves can be generally consumed and buried by earthworms, and then the leaves rot in the soil, and the oospores are released into the soil. They can germinate after a year, or they can last for several years in the soil. So as the soil is tilled or mixed, or it comes to the surface through the activities of earthworms, there's always a layer of soil in the vineyard that has these oospores in it. Whenever it rains in the spring and temperatures are sufficient, these spores germinate, and they produce a secondary spore that releases that tertiary spore, the zoospore, and that's the swimming one. So yes, they tend to overwinter right underneath the grapevines. Now, the spore that contain the zoospores, those can actually be wind dispersed or splashed dispersed, or they can travel in aerosols during, say, thunderstorms. And they can travel actually long distances. And there are downy mildews, for example, like downy mildew on tobacco, that can move hundreds, if not thousands of miles in a single growing season on upper air currents and in water droplets.
So is there any way to decrease the amount of spores in the soil, or is it something that you just have to treat it once it's actively impacting the plant?
There are many ways to control plant diseases. Some of these focus upon limiting the amount of the pathogen in the soil. And probably the easiest way to do that is not to try to kill them once they're in the soil, but prevent them from ever forming in the first place. So whatever you can do to keep the plants in a healthy state and avoid the disease in the first place, that's the best way to keep the pathogen out of the soil, is just don't get sick in the first place. So avoid the disease. Now, there's a lot of things you can do to do that. You can grow grapes in the right climate. If you're growing in a kind of an arid Mediterranean climate, you don't have problems with downy mildew. About 90% of the U.S. grape crop is grown in the state of California. You can find downy mildew in California, but it's not a major disease problem there because it's simply too arid for the disease to take off. The other thing you can do is grow a resistant variety, and this is really the best approach for a homeowner who doesn't want to be tied to spraying fungicides on the vines. There are many varieties of grapes that are out there that have substantial resistance to downy mildew, and those are great choices for a homeowner who's trying to grow grapes in a wet climate like the northeastern United States, or as you go south along the Atlantic seaboard, downy mildew becomes more and more of a problem.
So how do these mildews go about killing the plant? And then expanding upon that, how does a plant get, I assume, bred to be resistant to that?
Now, that's an interesting question, because a lot of these pathogens, it's not in their interest to kill their host. The powdery mildews are the best example of that. The group of powdery mildews are members of a category of plant pathogens that are referred to as biotrophs. They are obligate parasites. They can only live on living host tissue. So it's suicidal for a powdery mildew to kill its host. If the host dies, the mildew dies. The only time powdery mildews are really aggressive pathogens is in a relatively new association with a new host. For example, the North American grape powdery mildew meets for the first time the European wine grape. That they didn't evolve together, and it's a bit like a disease like smallpox getting into a new population. There's no natural resistance to it. So maybe in a few million years, this system is going to sort itself out, and what's left of the European wine grapes will be resistant to powdery mildew, or the virulence of grape powdery mildew will be attenuated through evolution. But right now, we're in the very early stages of that association. So not all pathogens are highly virulent and very destructive. Some are mild, and can be sometimes safely ignored. They're more cosmetic than they are destructive.
How do they go about actually damaging or killing the plant? Is it that they clog those breathing mechanisms, or?
Yeah, pathogens have a tremendous bag of tricks for sneaking into plants and causing trouble while they are there that benefits them and hurts the plant. So you have all kinds of pathogens. You have the very sophisticated pathogens that are like the obligate parasites, the biotrophs, that parasitize a plant. But, for example, the powdery mildews only parasitize the epidermal tissues of the plant, and they simply insert an absorptive organ into the plant, and they extract a small amount of nutrients out of the epidermis. So that's one approach. But then you have at the other end of the spectrum, you have the real kind of the thugs of the group. Now, these are the ones that go in, and they're called the necrotrophs. They live on dead tissue. Mm-hmm. So they can produce toxins that kill tissue in advance of their invasion. So they infect a plant, but they produce toxins that can be translocated throughout the plant, kill tissue in advance of the infection, and then they live on the dead tissue. You have what are called vascular wilt pathogens, which get into the vascular system, the xylem of the plant, and they clog that up and cause wilting of the plant. And they reproduce internally and then produce infectious spores externally on the dead tissue and everything in between.
Interesting.
So you have sophisticated, mild pathogens, and then you have the rather brutish pathogens that just plain kill.
Well, it certainly sounds like there's no shortage of varieties or severities or interesting diseases to study with plants.
Hence the need to specialize. It's a very broad field and a very challenging one in which to be a generalist.
Yeah, I imagine it's similar to physicians, like you mentioned. Being a specialist is incredibly important.
Well, initially we're all very broadly trained. We all follow very similar curricula in the schools, very similar to going into med school. You would take a similar set of core courses, and no matter what department you go to or what university you go to, you would receive the same foundational training in plant pathology, and then that's when the specialization really takes over, is at the later stages of the graduate program and in postgraduate training.
Are you able to find these plant pathology courses relatively easily, or is it difficult to find these courses?
It's not hard if you know where to look, but knowing where to look I think that's the hard part. As I said, we're a small profession, and we're one of the best kept secrets in the plant sciences, but we're not absent. We have a professional society. It's called the American Phytopathological Society, or APS is a lot easier way to find us. And our home base on the web would be apsnet.org. So that's the website of our professional society. And if anyone is interested in becoming a plant pathologist, I can tell you how it's done. And we need a lot of plant pathologists. The baby boomer generation is what populates the profession at the upper levels right now. So most of us are approaching retirement or have entered retirement at this point. So close to 20% of the profession is going to retire within the next 5 to 10 years.
Oh, my goodness.
That means we need a few thousand new plant pathologists to replace them. That's not because, as I said, they're not just in the universities, but they're spread across several employment sectors. I had mentioned that there were about 600 plant pathology faculty in the U.S. university system. Mm-hmm. By comparison, there's about 3,000 plant protection specialists just in the state of California.
Oh, wow.
And many of those have graduate degrees in plant pathology. So the private sector is actually much larger than the public sector in some cases.
So what is the process to becoming a plant pathologist?
Probably the biggest feeder system for our graduate programs are internships. Mm-hmm. Work experience internships, what's called an REU, a research experience for undergraduates. And these are all consolidated and listed on APSnet. So you can go to apsnet.org and look for the Internships and Careers tab, And there you can find dozens of internship opportunities. So if you're an undergraduate drifting about in your middle or late undergraduate career and you're not quite sure of what you'd like to do, and you would like to get into a profession that's kind of mission-oriented, where you're helping people and you get well paid for it, you might look into plant pathology and try an internship.
Sure.
These internships are paid, so it's at no cost to you. You will be flown into a university and paid for a summer internship working in a research program. And so you get to take the profession for a test drive.
That sounds like a great opportunity. I would imagine that, it'd be great to check things out and see if it's a good fit before investing the time and energy. And that sounds like a wonderful opportunity.
About 70 to 80% of the undergraduate students that enter an internship at my institution, this is the one I have the stats for, about 70 to 80% of them go on to graduate study in plant protection. So either in plant pathology or entomology or weed sciences. So these are all closely related professions. So once we show them what it's like to work as a plant pathologist, it's a very attractive career. It's a lot of fun.
That's some great retention numbers. Obviously, that kind of speaks for itself just in that.
The spread and growth of internship programs across the United States has been one of the greatest factors in driving graduate recruitment for our profession over the last 10 years. 10 years ago, maybe a little more than that now, we were facing a decline in enrollment in graduate programs across the United States. And that was reversed in part by growth in the internship programs as it became apparent that these were very effective as recruitment tools for the profession. Mm-hmm.
Yeah, that absolutely makes sense. And it's great to hear that it's been able to renew the interest in this line of work. So do you have any advice or recommendations, sort of shifting gears slightly, for the backyard gardener as far as any of these mildew concerns?
Well, really for any backyard gardener, the foundation of, I would say, an integrated pest management program would be site selection and variety selection. Grow what can grow well in your climate. If you are in a climate that is especially conducive for a disease like, let's say, fire blight of apple, don't go out and choose the variety that is the most susceptible variety of apple to that disease. You are setting yourself up for a dead apple tree. So site selection, knowing what zone you're in for climate, knowing your soil type, knowing what will grow there, and what varieties are susceptible to certain pests and what varieties are not. For most crops, there's a diversity of susceptibility to the diseases that prevail in your area. So choose carefully, and you can avoid a lot of the problems.
I think that's really helpful advice. Thank you.
That's the foundation of all disease management. If you have the option of growing something that is resistant, by all means grow it. If you don't know what that is, look around. If you see that a plant is particularly absent from your area, there's probably a good reason for that.
Well, David, thank you so much for sharing all of this information with me. I'm excited to learn what you do as a plant pathologist. Obviously, it sounds very interesting, and there's clearly a demand for it. And thank you for sharing your advice today. I'll, of course, share the links to your association in the show notes in case anybody would like to learn more. David, thank you so much for your time today.
It's been wonderful. Thank you for having me. It's been a pleasure.
Absolutely. And for those listening, thank you so much for joining me for another episode of Backyard Bounty, and we'll see you again next week.
For a behind-the-scenes sneak peek, receive episode notifications, or leave a question or comment for the show, text the word podcast to 719-292-3207, or visit heritageacresmarket.com/podcast.